All right, so lesson 10.5, we're going to take our previous units having to do with ratios and proportionality, and we are going to put them into play in the area of geometry. And we're going to talk about similar figures, and we're going to determine whether figures are similar or not. And then we're going to find missing dimensions or missing like side links and things like that in shapes. So we're going to apply our proportions and so on into the world of geometry. So first of all, let's talk about what it is for figures to be similar. Similar are figures that have the same shape but are not necessarily the same size. So in this particular case, you'll see here I got a couple triangles. You'll notice that they are the same shape, okay? One is like a photocopy of the other one, just reduced or enlarged depending on which direction you want to think of it. Or even here we have a couple similar rectangles. Again, same shape, but not the same size. Okay, so when we have similar, same shape, not same size. All right, so we're going to go through and we're going to determine whether shapes are similar or not. And there's two tests that you have to check. And in order for shapes to be similar, they must pass both tests. Okay, that is important. Must pass both tests. Now, test number one, and this is the one that I would do first, is to check the measures of their corresponding angles to see if they are the same. Okay, so now I'm going to go to the next slide. I'm going to come back to this. So here I have a couple similar figures, and in this case I'm going to tell you that they are similar. So the corresponding angles, and in this particular case, A corresponds to D, B corresponds to angle E, angle C corresponds to angle F. Okay, and so the one thing we have to realize is we've got to be able to identify those corresponding angles, and those angles for shapes to be similar must be the same size. So if A happens to be, say, it's maybe a 40-degree angle, okay, D must also be 40 degrees. B here looks like a right angle, so let's just say for the sake of argument right now it's 90 degrees. E must be 90 degrees, and so on. Okay, so for figures to be similar, the corresponding angles have to be the same length. Okay. Also, be careful in this particular case. You'll notice I've set the triangles in such a way that the long sides happen to be on the bottom. That may not be the case. You may have some triangles that are flipped and rotated and things. You have to figure out which angles are corresponding. Now, test number two, after checking the corresponding angles, and I would do test number one first, the one that I have listed here, because it's the quickest. And if it fails test number one, you don't even have to go to test number two, okay? You would be done. But test number two, this is where we set up some ratios of corresponding sides to see if they're proportional, okay? So now if I go back here, we've already talked about corresponding angles. Corresponding sides are those sides that match up with one another. Okay, so in this case, BC corresponds to EF. I've done these in colors. Those are, actually I misspoke. EF is not, and BC are not the longest sides. In this particular case, the blue sides would be the longest. Those would be the hypotenuses, hypotenusae, whatever the plural of hypotenuse is. In this case, the green sides happen to be our second longest, and then the red sides, A, B, and D, E. Okay, but we got to be able to match up those corresponding sides, and we'll set up some ratios. So let's go ahead and do some examples. And so first of all, tell whether the triangles are similar. So okay, let's locate our corresponding sides. Well, in this particular case, F corresponds to S. This is 34. That's 34. Okay, so we're good there. E corresponds to R. I have a 106 for R. I have a 106 for E. We're good. D corresponds to Q. Well, those are both 40-degree angles, so we're good. Passes test number one. But now we have to go to test number two. All right? So I have to match up and write ratios and check to see if the ratios of those corresponding sides are equal. So, okay. Side FE corresponds to SR. FE is 8 inches. SR is 24 inches. All right, so there's my ratio, which you'll notice this could reduce. Well, actually, no, I'll go ahead and reduce it right now. 8 goes into itself once. 8 goes into 24 3 times. So we have a 1 to 3 ratio there. is that equal to, I'll go down here, ED is 7. You'll notice I'm going left triangle over right triangle. That order matters. Over 21. And actually in this case I can reduce this as well, 1 over 3. Now because these ratios are equal, so far so good. Alright, let's check the last set of corresponding sides. FD is 12 inches over SQ, which is 36, and this also reduces to 1 over 3. Now because all three of these ratios are equal to one another, we've just passed test number 2. So angles FE, or triangle FED, is similar to, sorry, that's not the right one. Let's do the right one. Similar to, and if I went FED, I have to actually go SRQ. I've got to keep the corresponding angle letters. So F corresponds to S, so I got to write it first, and then E corresponds to R. I got to go second with that, and D. I can change the orders. I just got to make sure the corresponding angles are the same, are in the same order. So, all right, let's check another one. All right, so test number 1, corresponding angles have to be equal. E corresponds to L. Those are both 45-degree angles. Okay, so we're good there. I'm just going to go around the sort of the circle here. H corresponds to O. Those are both 90. Good there. All right, actually I haven't used green. N corresponds to G. Both 90 degrees. Yes, we're good. Okay. Keep going around. The last set of angles. M corresponds to F. Those are both listed at 135. Passes test number 1. Now we have to go to test number 2. All right, so ratios of corresponding sides have to be equal. I'm just going to start over here. EF is 15. That corresponds to LM. That is 6. 15 to 6, which these in this case you'll notice they both divide by 3, so 2 and 5. Alright, so we've got a 5 to 2 ratio there. Alright, let me change colors here. Alright, I'm going to go to the bottom, just because. Alright, EH is 20. That corresponds to 8. And if I, let's see, if I divide these both by what, 4, that is 5 and 2. So we're good so far, because I have two 5 to 2s. Alright, let's keep going around the horn. Alright, I'm going to go to the ends on this particular case, and I've got to go left, since I'm going left to right. 10 over 4. They both divide by 2, leaving 5 and 2. We're good so far. So if the top ends up being a 5 to 2 ratio, we're golden. And we have similar figures. 10 over 4, which both become 5 and 2. Similar. If even one of these ratios is not the same as the other side, or as the other ratios, it fails. But in this case, all 4 of our ratios are equal, therefore similar. If even one of them is off just a little bit, not similar. Alright, let's apply something here. A picture is 10 inches wide and 8 inches tall. To display the picture on a web page, the picture must be reduced to 3.5 inches tall. How wide should the picture be on the web page for the two pictures to be similar? And so what we're going to do here, and this is sort of the how-to, to find the side length, the missing side length, we want to set up proportions, ratios of corresponding sides. So on the previous slide, we were given the side lengths. In this case, we're not. So one of the things even that you might consider doing, let me get the proper, is you might want to even draw a picture. Okay, doesn't have to be a good picture. All right, but we're 10 inches wide and we're 8 inches tall. Okay, so that is our original. We're going to reduce it so we know it's getting smaller. And in this case, it's going to end up being 3.5 inches tall. We just don't know how wide it's going to be. All right. So I'm going to set up my ratio of corresponding sides here, and we'll have to realize the top corresponds to the top, the end corresponds to the end. And it doesn't actually matter that I wrote the dimensions on different ends. We know that it's a rectangle, so we know that they're the same. So, okay. So the top over the top, and I'm just going to go left to right. So 10 inches over W is equal to, left over right, 8 over 3.5. And don't freak out because we have a decimal in here. That's no big deal. If you have to, if you really have to, punch things into a calculator to get the work done. But okay, cross products. Because we know we solve ratios and proportions through cross products. 8W. Sorry, 8W is my cross product the one way. 10 times 3.5 is 35. Alright, so I'm going to go ahead. We undo our multiplication of 8 times W with division. So divide both sides of this equation by 8. Oops, W. So 3.5. And again, if you have to type it into a calculator, you can do the long division off to the side if you want to. Oh, sorry, this is a decimal. So 3.5 divided by 8 is, and no, that's not right. Alright, let me try this again. This is not 3.5. We multiplied by 10. It's 35. I was right without the decimal in the first place. 35 divided by 8 is 4.375. See, even teachers make mistakes every once in a while. I'm glad I noticed it, though, because it didn't make sense. And that's one of the things that we have to realize. And a good learning opportunity at this point is, does your answer make sense? Okay. One thing I know in this particular case is because 10 was bigger than 8 in the original shape, the top or the width was bigger than the height. My width better be bigger than the height. So if you don't end up with something larger than 3.5, you have a problem. And so that decimal in there, when I went, wait a second, that's not going to work out correctly. Yeah, it's because I put that decimal in and I shouldn't have. I multiplied 3.5 by 10. The decimal went to the end. So, all right, that will get you to your work and your practice. Again, showing your steps as always. Come see me when you need help. Good luck.